Am I audible to everyone?
Yes, sir.
Okay. So today we are going to study about electrochemical series. Nernst equation up to Nernst equation we have completed. Okay. Now see, before starting electrochemical series, we are going to study about SHE, that is a standard hydrogen electron. So just erase it. We will study about She first. SHE. And this is basically a standard hydrogen electron. A standard hydrogen electron. Now see, what is a standard hydrogen electrode? Basically, the electrochemical series that we have studied also in class 9, reactivity series, the value, according to the value they are arranged, and that value comes when hydrogen is taken as reference. That means when hydrogen is at cathode, and you know that at cathode there will be reduction. It should be understood that whenever I say cathode, that means there will be reduction, and if I'm saying at anode, that means there will be oxidation. So you can see at cathode, 2 hydrogen plus will gain 2 electron and it will form H2. And the electrode potential, or you can say reduction potential, will be 0. Since hydrogen is taken as a reference, that's why the value of this is 0. Also, at a node, you know that there will be oxidation. That means one hydrogen will lose 1 electron. So 2 hydrogen will lose 2 electrons. And again the same, E naught R will be equal to 0, because hydrogen is taken as a reference element. And with respect to this, all other element electrode potential of all other elements were calculated, reference element it is. So please write it. Then I'm going to write the series of electrochemical series. Darshan, is this clear? Rim and Samia. Let me know when you all are done with this.
Done, sir.
Very good. Now let's start electrochemical series. Electrochemical series. First, I'm going to write this series and then we will talk about it. In NCRT, the value given are from positive to negative, but here I'm going to write from negative to positive. So lithium, potassium, barium, strontium, calcium, sodium, magnesium, aluminum, manganese, zinc, chromium, iron, cadmium, cobalt, nickel, tin, and then lead. The value of electrode potential of all these elements are in negative. E naught R will be negative. We don't need to learn the uh, remember the value. We just need to focus which one is more reactive and which one is less reactive. And one more thing about this is that we can easily compare the value and we can easily predict whether which one has more oxidizing power or reducing power. These all are in negative. Then hydrogen comes, which has E naught R equals to 0. So if you are going from negative, 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 and then comes to 0, then start positive. Then start positive. Now after hydrogen that comes is copper, iodine, silver, mercury, bromine, platinum, oxygen, chlorine, gold, and then fluorine, and then fluorine. And the value of all these are in positive. So you can easily predict that the most negative value of E naught R will have of which element? Lithium. The most negative value. The most negative value is of lithium, and slowly decreasing, and then comes to 0, and then positive and increasing. And the most positive value of E naught R will have fluorine. Is this clear to everyone? You can see I am just writing like this: -10, -9, -8, then 0, then 1, 2, 3, 4, 5, then 10. Everyone getting it?
Yeah, sir.
Now see, the important thing is that if the value of E naught R is more, you know that, can anyone tell me which one is greater, -2 or +2? Which one is greater? Samia, Rim, and Darshan, which one is greater, -2 or +2? No answer. This is unexpected. Rim, -2 +2, which one is greater? Darshan, Samia, please let me know. No answer from you. Samia, Rim, am I audible to you? Samia, Rim, am I audible to you?
Sir, you're audible to me.
Okay, then speak up. Which one is greater? If you don't know, just let me know you don't know.
2
2. Which 2? -2 +2.
plus 2.
There, you need to think about it. +2, positive will be always greater than negative. If I'm asking you -2 and +1, which one is greater? Darshan and Samia, please let me know the answer. Which one is greater, +1 or -2?
+1.
+1. So positive value is greater. So always remember that the positive, if the value of any element of E naught R is greater than, that means that element is best oxidizing agent. So what I wanted to tell you is that this is electrochemical series, of which hydrogen is taken as a reference element and the value calculated E naught R. Now this is in decreasing order of negative. Most negative is this and most positive is this. This is the origin hydrogen, which has E naught R is equal to 0. Now we will talk about its characteristic. The element which have, or the ions which have more positive value, that means, or more value of E naught R, that means that is most oxidizing agent. And the value, the E naught R value of any species which is lesser, that means that is less oxidizing agent or more reducing agent. Are you getting my point? Samia, Rim, and Darshan?
Yes, sir.
Okay, please write it. Then I will write whatever I said to you right now. Darshan, is there any doubt in this?
No, sir. Done, sir.
Samia, are you done with this?
Yes, sir.
Okay. Now, write a point. That is okay. Okay, Darshan. Just let me know whenever you are not done with this, or you are done with this, or if you have any doubt in this. Okay, thank you, Darshan. Now moving to the next part. That is characteristics of electrochemical series. Characteristics of electrochemical series. So when we talk about characteristics of electrochemical series, so first of all, E naught R, E naught R of hydrogen equals to zero. Always remember that. E naught R of hydrogen is equal to zero. The second point, element lie above hydrogen. Element lie above hydrogen in this series that I just wrote. Above hydrogen have E naught R equals to negative. And the third element lie below hydrogen have E naught R equals to positive. Next point we can write. Now you can see from hydrogen, above hydrogen it is in negative and below hydrogen it is positive. That means top to bottom, E naught R increases. Top to bottom, E naught R increases. And the fifth point, lithium is on top. That means most negative. Most negative. Most negative, that means the lowest one. Most negative, lowest E naught R. E naught R. And fluorine at the bottom, that means most positive. That means largest E naught R. Largest E naught R. And always remember that lowest E naught R, that means E naught R has in negative lowest. That means this is best reducing agent, or you can call most a reducing agent, and this is most oxidizing agent. Everyone clear with this? Very easy.
Yes,
Yes
sir.
or no? Please write. Is there any test in previous class, previous week that I conducted? No test.
No, sir.
Okay. Today we are going to have a test for half an hour. That will be related to only the question will be related from the last class because Darshini you just joined in the last class. That's why only. Let me know when you are done with this.
Done, sir.
Very good. Darshan, are you done with this? Sorry. Okay, thank you. Now see, we have next topic of this electrochemical series, that is application of ECS, that means electrochemical series. Application of ECS, electrochemical series. The first application is reducing and oxidizing power. There will be question on this. Reducing and oxidizing power. Now see, what is reducing and oxidizing power? When we move from top to bottom, reducing power decreases, reducing power decreases. As you saw that lithium is most reducing agent. Now, when you move below lithium, the reducing power decreases and oxidizing power increases. Oxidizing power increases. Are you getting my point? Rim, Darshan, Sania, please do speak up.
Yeah, sir.
Okay. Now, when we talk about reactivity, so always remember that top to bottom, top to bottom, reactivity decreases. Top to bottom decreases. When we talk about reactivity in ECS, top to bottom, it decreases. Please write this. There are two applications. There will be more application also, but these two are also important. Please write it. Then after, we will talk about metal displacement and non-metal displacement.
Done, sir.
Done, everyone? Darshan? Darshan, please do reply. Now see, the next application, the third application is basically, it is about metal displacement. The displacement reaction we have learned in lower classes like 10th, 9th and 10th, metal displacement. So write a point, the metal which lie above in ECS, electrochemical series, can displace the metal from its salt, which lie below in ECS, below in ECS. You can see electrochemical series that copper can easily, wait, now see, basically zinc and copper, tin and copper. Tin can easily displace copper because tin lie above copper. Is that clear to everyone? Zinc also displaces copper from its salt solution CuSO4, but copper cannot displace zinc because zinc is more reactive than copper. Is that clear? So for this, I'm going to take an example. Zinc plus CuSO4 will give ZnSO4 plus Cu. Again, here it is Ag plus FeCl3. Now, no reaction. Since iron lie above Ag, so Ag cannot displace iron. So no reaction. Is that clear?
Yes, sir.
Please write. When it comes to non-metal displacement reaction, this sentence will be reversed. We will see what happens there. Please write it and let me know.
Done, sir.
Sami, are you done with this? Okay, no problem. Oh, Samia, this is your message. Okay. So, Samia, where were you? Up to which? So, this is characteristic of electrochemical series. Then application.
Yes,
It
sir.
is simple. This is very good. Then it comes about metal displacement reaction. Then it will be coming non-metal displacement. Non-metal displacement. Everyone done with this? Up to this? Please let
Yes, sir.
me know. Now, when it comes about non-metal displacement, I'm going to write a sentence. Please read it carefully. The non-metal which lie below in ECS. I already told you it will be the reverse. The displacement reaction statement will be reversed from this. In ECS, can displace the non-matter from its salt, which lie above in ECS. In the previous metal displacement, you can see the metal which lie above can displace the below element in ECS. But here you can see in non-metal displacement, the non-metal which lie below in ECS can displace the non-metal from its salt which lie above in ECS. For example, Br2 plus Ki will easily displace I2 because this I is here. Bromine can easily displace this, but iodine cannot displace bromine. Okay, the series for iodine, bromine, chlorine, and then comes fluorine. But if you are going to react I2 plus KCl, there will be no reaction. There will be no reaction because chlorine lies below iodine. That's why there will be no reaction. In case of non-metal displacement reaction, if any non-metal wants to displace a non-metal from its salt, then what you have to do, then the element should be above, the element should be below in ECS. Is that clear?
Yes, sir.
Bromine can displace iodine, chlorine can displace both bromine and iodine, fluorine can displace all of three, chlorine, bromine, iodine, but iodine cannot displace bromine. Bromine cannot displace chlorine. Chlorine cannot displace fluorine. Please write it. It should be clear that when E naught R value increases, reducing power decreases and oxidizing power increases. I will tell you about this soon. Please write it and then we will talk about it. Madhya, today we are studying about electrochemical series.
Okay, sir.
So just let them write and then I'm going to slide it up and you will take a screenshot and I'll try to explain it again.
Okay, sir.
Let me know when everyone done with this one by one.
Done, sir.
Samia and Darshan waiting for your answer. Very good, thank you. Samia, are you done with this?
Yes, sir.
So wait a minute. The topic of electrochemical series is completed. Now I'm going to practice some questions. So wait a minute, all of you. Madhya, today's lecture started from here. See, the standard hydrogen electrode potential, a standard hydrogen electrode. So this electrode potential for every species or elements are calculated on when hydrogen is taken as reference element. That's why hydrogen, where whichever cathode, if hydrogen present, the electrode potential will be zero. In both cases, anode or cathode. As you know that cathode means reduction, anode means oxidation. Is that clear, Madhya?
Yes, sir.
This screenshot. Let me know. Done.
Sir, I take this screenshot, yes.
Very good. Thank you. Now see, this is electrochemical series. And you know, lithium is most negative. The electrochemical series is in order of most negative, then in decreasing order of negative, 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 negative. Then hydrogen comes, which is positive, and then sorry, hydrogen which is zero, and then again zero to positive going. Always remember that E naught R increasing, that means oxidizing power, decreasing, that means reducing power, increasing. Is that clear? Is that
Yes.
clear, everyone? Now say, I want answer from everyone. There is an element X which has a value 1.35 or 53 volt minus Y which has a value 1.45 volt, Z which has a value 1.4 volt. Now I want arrange this in increasing order of reducing power. Arrange this in increasing order of reducing power, increasing or decreasing order, whatever you are just let me know which one is a strongest, which one will have a strongest reducing power and lowest reducing power, weakest reducing power.
Z has the most reducing power and X has the least.
What you just said, Nadia, I wasn't able to hear. Highest
I
reducing
s-
power.
it's Z.
Very good. You can see the greater the value, you know, greater the value of E naught R. And if you are going to choose the greater value, the least in negative, this is the greater. That means Z will have the most reducing power, and then Y, and then X. If the answer just changes, what is the oxidizing power? Oxidizing power in order to oxidizing power. So X, then Y, then Z. Rain, Darshan, Rim, are you there? Darshan, is that clear?
Yeah, sir.
Okay. Yes, Darshan. I was asking the question. Hmm. Do you have any doubt in this example?
No, sir.
Okay, thank you. Darshan? Okay. So, Madhya, this was about it. Now, thank you. Now, the next topic is basically characteristics of electrochemical series. Characteristics of electrochemical series. So E naught R, value of E naught R for hydrogen 0. Elements lie above hydrogen in this series that I have written will be negative. But if you will look into NCRT, it is in opposite, like positive to negative it has given. Okay. But the concept doesn't change. E naught R value increases, oxidizing power increases, reducing power decreases. Are you getting my point, everyone? Elements lie below hydrogen according to my series that I have written is positive, but in NCRT it is opposite. Also, top to bottom, E naught R increases. Why? Because negative to positive, going from negative to zero, then positive. That's why, according to this series, top to bottom, E naught R increases. Now, lithium on the top. Lithium on the top, that means most negative, and that means most negative, that means lowest value of E naught R. And if there is lowest value of E naught R, that means best reducing agent, or you can call it reducing power. Okay. Now F is on the bottom of the series, that means most positive value of E naught R, that means most oxidizing power it will have. Madhya, did you take the screenshot?
Yes, sir.
Application of ECS. First, we are going to compare for uh, oxidizing and reducing power, reducing and oxidizing power, top to bottom. According to the my series, top to bottom, E naught R value increases. That's why reducing power decreases. and oxidizing power increases. Reactivity top to bottom decreases. Reactivity top to bottom decreases. Now just take a screenshot. Done.
Done, sir.
Now the third application is metal displacement reaction. Always remember that a metal which is above in electrochemical series can easily displace a metal from its salt which lie below that metal. So this is the metal which lie above in ECS can displace the metal from its salt which lie below in ECS. Like Zn plus CuSO4, it will give ZnSO4 plus Cu. That means zinc can easily replace copper because zinc lie above copper. Where if you are going to react Ag with FeCl3, the reaction will not occur because Ag cannot replace iron as iron lie above Ag. Okay. Done the screenshot.
Yes, sir, I do.
Now see, this is non-metal displacement reaction. Non-metal displacement reaction is opposite of metal displacement reaction. What happens here is non-metal which lie below in ACS can displace the non-metal from its salt which lie above in ECS. Opposite of metal displacement. You can see Br to Ki. I can easily be replaced by Br. So it becomes KBr and I, because this is the series iodine, bromine, Cl, and fluorine. Fluorine can easily replace chlorine, bromine, iodine. Chlorine cannot displace fluorine but can displace bromine and iodine. Is that clear? Everyone?
Yes, sir.
Thank you. Thank you. Now see, we have some questions. Please write. It is given that CO plus 3 takes 1 electron and convert into CO plus 2, which has E naught value plus 1.81 volt. Again, Pb plus 4 gains 2 electrons and convert into Pb plus 2, which has E naught value equals to plus 1.67 volt. Ce plus 4 gains 1 electron and goes into Ce plus 3, which has E naught value plus 1.61 volt. Now Bi plus 3, this one, gains 3 electrons and converted into Bi, and it has a value E naught will be equal to plus 0.20 volt. Write in increasing order of, write in increasing order of oxidizing power. You need to write it in increasing order of oxidizing power. There is only one concept. Please do this. Any answer? Madhya, Rim, Samia, any answer?
Sir, is the answer B, I, C, PB, and then
Wait a
CO?
minute, Madhya. Let me know. Is it in increasing order?
Yes, sir, in increasing order.
That means BI is the lowest, right?
Yes.
Very good. Again, now tell me the answer. BI plus, sorry. BI plus 3, then
CE,
CE plus 4, then
PB plus 2, and then CO plus 2.
PB plus 4, na? We are talking about this.
Oh,
That's why I'm
yes,
taking
PB
this.
plus 4, and then CO plus 3.
CO plus 3. Let me check the chat box. CO plus 3. Very good, Samia. Very good. Darshan and Rim, do you have any problem in this? I already told you. E naught R value increases. That means reducing power decreases and oxidizing power increases. Now you can see in the question, it has been asked about oxidizing power. So the species which have most E naught R value will have more oxidizing power. So just choose it. The CO plus 3 will have 1 plus 1.81 maximum. So it will have more oxidizing power than this PB plus 4, then CA plus 4, BI plus 3. Is that clear to everyone? Rim and Darshan especially.
Yes, sir.
Okay, can I change the slide?
Yes, sir.
Okay, Rim and Darshan, are you done with this? Can I change the slide?
Yes.
Now, again, same question I'm going to give you. Always remember, if there will be any test or exams from this chapter, this question, this topic is very famous. They always ask, the examiner always asks. Consider the following. Reduction processes. Consider the following reduction process. Zn plus 2 electron will give Zn in solid. There is a next also given that E naught will be equal to minus 0.76 volt. Now Ca plus 2 electron, it will be converted into calcium solid. Mg plus 2 electron, it will be converted into Mg solid. Now Ni plus 2 electron, it is converted into Ni solid. Now it is also given that E naught is equal to minus 2.87 volt. Here E naught value is minus 2.36 volt. Here E naught value is minus 0.25 volt. Writing increasing order of reducing power. Reducing. Please do it carefully. I'm here waiting for your answer.
Sir, Ca plus 2 is greater.
Sir, it is Ca plus 2, Mg plus 2, Zn plus 2, and then Ni plus 2.
What you just said, sorry, I couldn't hear you. Nadia?
Sir, it is Ca, Mg, Zn, and then Ni.
Okay, is it in increasing or decreasing order?
Increasing order.
Ca is most, sorry, least. Are you suggesting this? Ca is least.
Yes.
Can you read the question again? It is asking about reducing power. The previous question was about oxidizing power. So if you are going to write anything, just focus on this. If E naught R increases, that means the reducing power decreases, oxidizing power increases. So if you want reducing power to be maximum, that means E naught R should have the lowest value, then reducing power increases and oxidizing power decreases. Nadia?
Yes, sir.
This is also a wrong answer, I think, Samya. So see, what will be the answer? See, the least value of E naught R will have the most reducing power. So which one will have the least value? Minus 2.87. More negative value, very smaller value. So this calcium is the most reducing power. Then we can think of this magnesium. Then you can see after calcium it is magnesium and then zinc, and the lowest will have nickel. Is that clear or not? What I told you is that E naught R increases, reducing power decreases. So you can see the lowest value of E naught R. The lowest value of E naught R is minus 0.25. So wait a minute. Lowest value of E naught R is minus 2.87. That's why reducing power maximum will be of calcium. Is that clear?
Yes, sir.
Yes, sir.
Now next question. Darshan. Now see, the next question is, given that E naught of O2 slash H2O is given as plus 1.23 volt and E naught of S2O8, E naught of S2O8 slash, this is in minus 2, SO4 minus 2 has a value 2.05 volt. It is also given that E naught Br2 slash Br minus is equal to plus 1.9, sorry, 1.09 volt, and it is also given that E naught Au plus 3 slash Au is equal to plus 1.4 volt. Now the question is, the strongest oxidizing agent. The strongest oxidizing agent is.
It's S2O8 minus 2 and SO4
Who is
minus 2.
this? S208 minus 2. Any other answer? Rim and Samia.
So it's S2O minus 2.
Yes, S208 minus 2. Because you can see that very good. It is in positive, so most oxidizing agent is this. Very good, everyone. So we have done this question, and this question. Now I'm going to give another question. That is given E0 Cl2 slash Cl minus is equal to 1.36 volt. E0 Cr plus 3 slash Cr is equal to minus 0.74 volt. Cr207 minus 2 slash Cr plus 3 will be equal to 1.33 volt. E0 MnO4 minus slash Mn plus 2 is equal to 1.51 volt. I'm going to give option also. Among the following, the strongest reducing agent, the strongest reducing agent is, I'm going to give you an option, A is chromium, B is Mn plus 2, C is Cr plus 3, D is Cl minus. Please do this question.
Sir, it is A.
Madhya, what you just said?
I told answer is A.
Any other answer? Rain?
Yeah, sir, it's A.
Darshan? Very good. So you can see it is talking about the strongest reducing agent. Very good, Samia. I got your answer. You can see the strongest reducing agent. Best reducing agent is the one which has, oh, wait a minute. Reducing agent, that means oxidizes itself. Oxidizes itself. Okay, very good. Now you can see best reducing agent is the one which has E naught R value in negative. More negative, more reducing agent it is. So the answer is this. Okay. Now the next question also comes out to be. Given E naught Cr plus 3 slash Cr is equal to, wait a minute. Okay, minus 0.74 volt. E naught MnO4 minus slash Mn plus 2. Before giving answer, check your cross check it at least once. E naught Cr 207 minus 2 slash Cr plus 3 will be equal to 1.33 volt. E naught Cl slash Cl minus will be equal to 1.36 volt. Based on the data given. Oh wow. I will give option also. The strongest oxidizing agent will the strongest oxidizing agent will be chlorine Cr plus 3 Mn plus 2 and D is MnO4 minus.
Sir, is the answer
Sir,
D?
D.
Any other answer D or I heard answer D and
Sir,
the
I also
second
said D.
rim.
Yeah, I also said D.
Okay. Any other answer apart from D?
Sir, it is
C.
D only.
Wait a minute. I'm just opening some other PDFs. Okay. So any answer apart from D is C. That is a wrong answer. You can see the strongest oxidizing agent, the E naught value, the species which have most positive value. You can go for this. So most positive value is this. So either which one it will be, Mn plus 2 or MnO4 minus. So we are going for oxidizing agent. So oxidizing agent, that means reduces itself, yes or no? Oxidizing agent is the one which reduces itself, or reducing agent is the one which oxidizes itself. Now you can see or look at it. The oxidation state of +7 to +2 it is going. So which one will be the oxidizing agent? MnO4 minus, not Mn plus 2. Okay. After the reaction, it becomes Mn plus 2. Is that clear, Samia? Darshan? Darshan and Samia, please speak up. Okay, thank you. Now questions are also asked like this. These all questions are from JEE Mains that I had just given you. The standard reduction potential, the standard reduction potential values of three metallic cations, X, Y, Z are 0.52, -3.03, and -1.18 volt respectively. Right, in decreasing order of reducing power. Please write. Just let me know the answer. Very easy it is.
Sir, is the answer X, Z, and then Y?
What you just said?
The answer is X, Z, and then Y.
Is it in decreasing or increasing order?
Sir, it is in decreasing order.
X, Z, and Y. Like this.
Yes.
You can see decreasing order of reducing power.
Sir,
We need
it's Y, Z, and X.
yes, it will be. Reducing power, E naught R increases, reducing power decreases. So go for E naught R, which has maximum value, this X. That means reducing power is lesser for a smaller for X. And then minus 3.03 and 1.18. Which one is lower? This is, which one is bigger, minus 3.03 or minus 1.18? So this is Z and then Y. This will be the answer.
Rim,
Yeah, sir.
this will be the answer, right?
Yeah.
Nadia? Nadia, got it, or
Yes,
if you
sir, I
need
got
another
it.
explanation, let me know.
No, I got it.
Very good. Wait a minute. Darshan, you didn't give any answer. That's quite bad.
Am I audible?
Yeah, sir.
Okay, thank you. Okay, I'm going to give. That means you should make your every topic that much strong that if any questions will be from that topic, you are not gonna say that you cannot do it. Like this topic, we have completed almost every type of question. The standard reduction potential. At 298 Kelvin for the following half cells are given. Zn plus 2 electron is giving us zinc in solid, which has E naught value minus 0.76 volt. Again, Cr plus 3 electron is given. Cr in solid, E naught value is minus 0.740 volt. Right with so this is the value given in the question, and what we need to do, this is the last question of this. which is the strongest oxidizing reducing agent, which is the strongest reducing agent. I'm going to give option. Like the option is A is zinc, B is chromium, C is H2, and D is Fe plus 2. Please do this. After this,
Sir, A.
who is this A?
Green.
Sir, the answer is A.
Any other answer, Samia? So I think you can do any question on this topic. That's quite impressive. Very good. Samia,
Yes, sir.
A is the answer, right?
Yes.
Okay. So this is it for electrochemical series. In the next class, we are going to study about electrolytic cell. And there will be cases like in molten state, in aqueous solution and all that. Okay. So the next question is not on ECS. The standard gives energy for the given cell, for the given cell reaction, in kilojoule per mole at 298 Kelvin is zinc in solid react with Cu plus 2 in aqueous, gives you Zn plus 2 in aqueous plus Cu in solid. E naught has a value 2 volt at 298 Kelvin, and it is given that Faraday's constant has a value 96,000 Coulomb per mole. Please calculate the value of delta G naught. Very easy question. Any answer? Madiha, Rin? Please do
Sir,
speak up.
is it minus 386?
Let's see. Delta G naught has a value formula that is minus NF E naught cell. Now you can see minus number of electron transferred. You can see 0 to plus 2 it is going. So 2 into Faraday's has value 96,000 E naught into E naught cell has a value 2. So just solve it, you will get your answer in Joule. This relation I have already taught you in the previous lectures. Yes or no? Did you calculate in this way, Rin?
Yeah, sir.
Okay, that's good. So you will get your answer. Let me know when you are done with this. So in the next class, I'm going to
Sir,
conduct
I'm
a test.
changing my answer. It's minus 384.
Just calculate it.
Yeah, I did it again.
Wait a minute. It only 3,84,000 joule. If you are going to divide it by 1,000, you will get your answer. Oh, wait a minute. Divided by 1,000, you will get 384 kilojoule. Yes or no?
Yeah.
Okay. So Madhya, this is it for today. In the next class, I'm going to conduct the test. Do you have any doubt? If you have any doubt, just ask me, please.
No, sir.
Okay.